Good morning, Dr. Romanbabu.
Good morning,
Good morning to each and every participant. So now we are here. So again, FDP on rehabilitation, retrofitting of structures. Day 3, morning session. So it's my privilege to introduce today's speaker, Dr. Romanbabu. He completed his BTech from Manipur Institute of Technology and MTech from NIT Silchar and PhD from IIT Delhi. He worked as assistant professor in Sharda University, Greater Noida. Later, he worked as senior project scientist at IIT Delhi and as an assistant professor in NIT Waranga. At present, he is working with IIT Tirupati as assistant professor. His research areas include seismic evaluation and retrofitting of structures, supplemental damping and energy dissipating devices, performance-based seismic design of structures, fiber-reinforced concrete, large-scale testing of structures using quasi-static and pseudodynamic methods, numerical method modeling of reinforced concrete and steel structures. He has wide understanding and exposure in seismic evaluation of and retrofitting of seismic structures, seismic failed structures. He has to his credit and 20 research papers in various refereed national and international journals and conferences. He filed a patent for combined metallic yielding device. He has received Young Author Best Paper Award in Structural Engineering Convention 2014 Delhi. So I welcome you, sir. Thank you very much. So for being on board for this FDP. So now I request Dr. Romanbabu to take up the session.
Okay. Thank you, Professor. So now before sharing my slides, so I would like to just good morning to everyone. In this session who are participated, and this same link is already, I think, streamlined on the YouTube. And those who are watching to YouTube also, good morning from my side. And I really appreciate that Professor is already the program. He's the organizer, and in this difficult time, he utilized the time effectively, and he arranged such a program in the right time. So especially this program is dedicated for the faculty who are working in the teaching lines, and as well as this is not only for the faculty. I hope, my opinion, it will be well benefit for this practice engineers as well as the research scholar based the higher level study students also. And finally, I like to thank to the Mr. Yuvraj who are coordinating this entire program and session. So I really appreciate your hard work and efforts. So now I will start my presentation. So now I'll share my screen. Yeah. So Professor Reddy, is it visible?
Yeah, sir. Okay. It's very clear.
So yeah. So before starting the next slide, so I would like to give a small introduction about this seismic repair, rehabilitation, and the retrofitting. So in online, so this program, the title of my presentation is mentioned only as a repair, but intentionally here I include rehabilitation and the retrofitting. And most of us, including the faculty as well as the practice engineer, we are using these three terminology in an ineffective way. So without understanding much logic behind this repair, rehabilitation, retrofitting, we are simply using very casually. But as an expert or as a researcher, we should not use this three terminology in a very casual way. So repair has their own significant definition, rehabilitation, as well as retrofitting also. So those things I can cover one by one. What is a rehabilitation? What is a repair? What is a retrofitting? And in the current scenario, that's all these three terms, repair, rehabilitation, and retrofitting are quite demand as per the in the current situation, because our natural hazards are quite common. Natural hazards like, for example, cyclone, and the wind, this one, any kind of earthquake, so tsunami, any kind of these hazards are frequently happen in day-to-day life, and structures should able to sustain from this natural hazard loads. So, but some of the structure, not some, most of the all structures constructed a long time back, and at this moment, those structures are not uh, their load resisting capacity is not sufficient as per the that's expected hazard. And in the last 2-3 days, most of the panelists discussed in a different aspect, and even yesterday itself, repair rehabilitation, some topic already discussed. So for me today, I'll more focus towards the uh, mechanics of the rehabilitation and the design philosophy, as well as how to select the retrofitting technology, methods for a particular structure. That will be my focus area. So before going to the that's next uh, level, so I would like to give a small briefing about my contents of the today topic. And first of all, I would like to talk about something about earthquake, how earthquake is coming. And intentionally, why I mentioned earthquake is that right now I mentioned that structures should be able to resist the natural hazard. So earthquake is one of the natural hazard. So my expertise area is earthquake. So today my focus will be the structure, how to design the earthquake resistance, and how to choose the retrofitting techniques as per earthquake loading. So first of all, let's try to understand how earthquake came in the picture, and what are the difficulties in the earthquake. That I will give a small briefing. After that, the common irregularities in a building, that I'll explain, and that's the why the retrofitting is coming in the picture, because of this common irregularity only. And what are the available retrofitting methods like local and the global, and the design philosophy of those retrofitting scheme, and using a performance-based design. And later on, I will just focus on the energy absorber and energy dissipators as a retrofit technique. So these are my contents of the today talk. So first of all, let's focus on the how the earthquake came in the picture. Let's see. So many people already have the personal experience of earthquake in the real life, and some of us not have that type of the experience. So the earthquake can be classified into two ways. One is the natural and one is the man-made. And under the natural, there's a tectonic movement is the one of the major causes for the earthquake, and the volcanic eruption and the rock falls. These three are the major contribution from the natural source point of view. And in the man-made point of view, like a blast or reservoir induced and a mining induced. These are the man-made earthquake. So for me, I will more focus towards the natural based earthquake, especially this tectonic movement. So before coming to this tectonic movement, let's have a look what are the past history of our Earth. And if you look back 225 million years ago, our Earth crust is a kind of a solid plate, and it's interconnected. And inside our Earth, that inner core and the mantle area, this is a liquid base, and this is highly radioactive material. And due to the Earth movement, the inside liquid also keeps moving, and in a different direction. And due to this radioactive element movement, uh, that's automatically that's the positive and the negative polarities develop, and due to that polarity, the plates are moving each other. Some are ripples, some are away each other. So that movement started long time years back, and due to that movement 135 million years back, now the plates are started splitting each other. Again, if you come to the 65 million year back, that plates are again more and more moving apart each other. So this is the current status of the our Earth, and right now our country is here. So this is the a small history about our Earth crust. So now let's come to the tectonic movement. In the tectonic movement, what is that? Due to that Earth crust movement, I told right now, some are repulsive, some are collision, some are sliding, and those due to the sliding, that's earthquake might be caused, and that sliding can be classified into three ways. One is a dip slip, so it means the vertical direction. So the plates are sliding in the vertically, and second is a kind of strike slip. This is a horizontal type. The plates are sliding each other horizontally, and third is a kind of oblique. This is a combination of the vertical as well as the horizontal. So it's quite complicated. Based on this movement, the different type of the earthquake also will come in the picture. And today I will not talk very deep about those earthquake. So S wave, L wave, different kind of the waves are there. So those wave will be generated based on this type of deformation. Okay, now I just showing some of the pictures which is related to the just now I explained. This is the dip slip type. So see, I took from the internet source, and this is the uh, Mosira Canyon's Dead Valley. Again, this is another that strike slip, and in China. And this is the one of the pictures which I took from the net again. This is a New Zealand earthquake. This is the New Zealand earthquake 2010, and this is 1976, that China earthquake. So railway tracks also deformed. So such type of the that tectonic movement can be observed from the valley base or from the civil infrastructure that we can observe. So now you can see how difficult.
Dr. Romanbabu, sorry for interruption. There
Yes.
is a background noise that is coming. So could you please check?
Okay, sure.
Somebody is speaking, I think so. Otherwise, use earphones so that.
Is it clear, sir?
Yeah, sir. Go ahead. Sir.
Okay. Is there any noises at this moment?
No, sir.
Okay, fine. So now, again, some of this tectonic movement can be observed. This fault lines, actually, the two tectonic plates might be merging each other, and those merging can be visible from the very from the clear eye also. So some are not visible, some are visible. So this is the San Francisco that fall in the California, and the same tectonic movement. This you can observe from the satellite point of view also. This is the line right now what I shown you, and similarly another one, Rip Valley. This also kind of the region between the two tectonic plates. So such type of the movements, some are visible and some are not visible. Whatever I'm showing here, this is only visible tectonic plates. So now coming to the Indian scenario. So just now I mentioned that 225 million years back that tectonic movement started, and the Indian portion, that plate that was quite new, and due to that movement is keep moving towards the Eurasian plate. The Eurasian plate is this side, and this is quite old compared to the Indian plate. The Eurasian plate is quite old, and it's in every year so that the movement is 5 centimeter per year. In that speed, the plate is moving. So as a result, the height of the Himalayan is quite keep increasing day by day, and due to that reason, and that that Himalayan belts are highly seismic zone. So this is the one of the mechanism represented as a graphically. So this is the Eurasian plate, and that's the Indian plate. The Indian plate is just moving below the Eurasian. So as a result, in this boundary area, the Himalayan has formed, and the height is keep increasing each and every year. So due to that, once if earthquake is generated from the crust or the mantle region, the earthquake wave will be generated in the multiple dimension, and it might be the surface wave or it might be a body wave. And in case of the surface wave, okay, so surface wave are coming on the surface, and so based on that surface and body wave, the failure in the structure also has a different pattern you can observe. So today I'll talk about mainly on the surface wave-based earthquake. And so this is the figure which I took from the severe Murti data report. And and based on this earthquake, the level of the damage on the structure uh, can be classified in the performance-based design, the minor level earthquake, the major level earthquake, and the moderate level earthquake that can be classified. So that I'll cover in the after some few slides. So I'll give you one example of how the earthquake occur and how the heat, this wave is generated. And sometimes we might be heard the term called the aftershock and the foreshock. And the foreshock is before hitting the major earthquake, at least some few seconds before, some small tremor might come. So that's called a foreshock. And aftershock means just after the major earthquake, some small intensity earthquake might be keep generated. That is called a kind of the aftershock. So, but in this definition, the most of us might understand that aftershock and the main shock, the time gap might be a small, it might be 2 seconds or maybe 5 seconds or maybe even 1 minute, 2 minutes, but it is not mandatory. Sometimes the aftershock and the major shock, the gap might be in terms of the year also. So that's why I'm just taking one example. Most of us already have the experience of the 2004 Sumatra earthquake. And due to that earthquake, the tsunami came, and that tsunami hit to the coastal region of the South Indian region. So this red area is highly affected during that tsunami. And that earthquake was happened in 2004, December 26. And as I mentioned right now, the epicenter of the earthquake is here, and the wave movement is moving in such a way that, and so due to that movement, the earth plate is moving in the wavy form, and finally, this portion, the Indian plate is moved towards, and but Eurasian plate is here and it's resisting. And here the energy is quite high. The moment when the wave reaches to here, the energy is low. And due to that low energy and this collision portion, the plate is not able to move inside, but it was holding. And due to that holding, you know what happened in 2000. So this is a tsunami affected area. Uh, there is one earthquake in 2005. This is called the Kashmir earthquake. And you know what happened this earthquake? And in this earthquake, uh, so if you look in the gym, we are just playing such type of the rough just for our workout. And if you look here, when you apply the amplitude, this is slow down and finally it is diminished. Like that, when the earthquake wave came here and somehow it's slow down here, but and there's this obstruction and the wave is coming something like this, and this portion tried to go down, but due to this restriction, it was not able to move inside. And the moment the energies keep accumulated, and finally after almost a year, means from 2004 December to 2005 this one October is almost 10 months, and energies keep accumulated, and after reaching one threshold point, suddenly this person goes inside, and this person goes inside, and then this become a flat plate later stage. So at that time the earthquake was generated. So it means some of us already having this idea, and some of you might not be having. So means if you look, the Kashmir earthquake and the Sumatra earthquake, they are correlated, and some of us might be thinking what are the independent earthquake, but what are the dependent earthquake. So a Kashmir earthquake happened because of the Sumatra earthquake. So means it's in every earthquake, some are correlated, some are non-correlated. And so this is the affected area during this Kashmir earthquake. This total entire valley was diminished. And now this is a small overview about this earthquake and how much the danger in the earthquake and how structures behave during the earthquake. Let's have a small video from here. Let's have a see. And this video just I took from YouTube, and this is from Nepal earthquake 2015. And during this earthquake, rest of the portions are quite safe. Only this structure got collapsed, and this structure is a kind of the single degree of freedom type, and the columns are quite flat. flexible and a heavy mass is exists at the top. So structure got collapsed. And such type of the structure are very vulnerable during the earthquake time. And so based on that level of damage, now we can identify what type of the damage is acceptable for our earthquake. And during the minor earthquake, some mild damage, moderate earthquake, what level of the damage, and a strong earthquake, what type of the damage is acceptable. So this all three category of the damage I will discuss later stage of my presentation. So along with the performance-based seismic design, simply I'm giving here some small brief information. So now again, looking back to the some of the structure in existing structure, this is the total the overbridge was collapsed in 1995 Kobe earthquake. And if you look the superstructure is there's no any damage, but the entire the bridge piers are got collapsed, and this is due to the shear damage. And how to tackle such type of the problem in the upcoming earthquake, and how to resist, and how to make the structure in the safe. That's the role of our rehabilitation and the retrofitting. So finally, I'll go to that direction. So again, this is a Loma Prieta earthquake. Another the overbridge got collapsed, and here during the earthquake, structure might be very safe, but due to your mode of the construction, intentionally you make the structure to make fail, but structures will not fail, but you just make in such a, you construct the structure in such a way that automatically structure is going to fail. But if you construct the same structure in a different place, the structure will not fail. And that type of the one of the construction method is called this is a very closely compact structure. And at the time, you know what happened, there's a one effect called a pounding effect. And let's have a look here how structure got failed. So in this two building, one structure, both structure have a different height of the story, and the shorter story structure is hitting to the middle of the higher story. So it means very soft area. This is a very soft area. So this is called a pounding effect. But if you construct the height of the story at the same level, then there should not be such type of the failure. So we should be very careful, and especially in the town planning and the municipalities, we should give a proper instruction while you make the town planning policy. The structure should be at the same level. Otherwise, unnecessary, your structure design might be doing very perfect job, but during the earthquake, due to this type of the pounding effect, your structure also might got collapse. So in another concern, the earthquake is very difficult. After following all the design criteria, still we can't say structure will be strong or not. This is the one of the market complex in Imphal, and there was a earthquake in 2016, January 4, and that was a 7.6 magnitude earthquake. And the market complex is constructed inaugurated in 2006, just after 10 years of the life that 7.6 earthquake magnitude came. And this market is quite a famous earthquake, especially for the lady, and thousands of people are gathering at one time. So fortunately, the earthquake came in early morning around 4:30 a.m. and because of that, no one was got dead, or the number of casualty was very less. But if you look the structural performance, the entire column got damaged. And structure did not collapse, but a column was damaged severely. And if you look very closely, and this column, the stirrups as well as a main reinforcement, they are provided as per the design, and even the construction quality was quite good, but still structure got damaged. And such a typical observation during the earthquake is always making confusion to the designer of what to do. After following the code practice, still structure got damaged, and in that condition, what type of the precaution need to be taken care. So especially that structure got damaged because of that's soft story mechanism. So in the later stage, I will explain what is a soft story mechanism and how to avoid that soft story. That also I will be explain very extensively. And one more aspect. So this is the staircase in the same building. Staircase got damaged, but as per the earthquake design philosophy, and your structure might be minor damage, but such type of the vertical movement, like especially the staircase, should not be any damage, because because of your life safety, your building might be minor damage, but if you have time for evacuate without this staircase, how to evacuate a structure? That's the concern. So for the life safety, there should not be any damage in the staircase during the earthquake, and that. But actually, this staircase also designed very as per the criteria. They did a proper design, but still that staircase got fell during that earthquake. And now coming to the Indian seismic code. So Indian seismic code has classified the 4 earthquake zone as per current scenario: seismic zone 2, 3, 4, and 5. But in olden seismic code, there was a zone 1 also was exist, but in the later stage, the zone 1 and the zone 2 merged together and finally converted as a zone 2. And zone 2 seismic zone factor is 0.1, and zone 5 is a 0.36. And this red zone areas are highly seismic zone 5. And the, so now we are in the Tirupati. So Tirupati is under the seismic zone 3. So it means whenever you do any design, so of course the South Indian regions are quite stable for the seismic point of view, but still we are under the zone 3. So we have to consider that earthquake loading while designing the structure. So now overall information about this seismic and how structure behave, I give a small briefing. So I did not spend much time on the earthquake, so most of us might be having that information. That's why I did not spend much on time. But anyway, let's come to the some irregularity in the building and which causes for seismic strengthening. And so some of the irregularities can't be avoided, and some irregularities we can ignore it. And this animation figure I took from the NICE Kanpur website, and here you can see different type of the irregularities: the setback and slopy ground and hanging floating and RC shear wall discontinuity and the weak story. So among these irregularities, weak story and the slopy, this these three category can't be avoided, because at any condition we require such type of the structure. So but anyway, rest of the structure category can be ignored and we can convert as a simplified form. And a similar kind of the figure even you can get from the IS 1893 2016 version. And again, when we construct this reinforced concrete shear wall, there should be discontinuity is there. So the reinforced concrete shear wall should be constructed from the foundation level, and it should continue at the end of the structure, means up to top level. But anyway, this concept is applicable only for reinforced concrete. But when you use the steel plate shear wall, you can provide some discontinuity as well. So means the steel plate shear wall concept and the reinforced concrete shear wall concept are quite different. Again, this is another kind of the irregularity. The irregularity might be in the plan area, or might be in the structure, might be too long or too tall, or might be too large. So this also can be converted this simple small structure, making as a easily controllable structure. But in case of tall structure, there is no any replacement method. But at the time, what to do? How to control this vibration? During the earthquake time, this will be vibrates in the 2 and 4. How to control that type of the movement? And even for this mass level structure, the lateral load carrying capacity will be quite high. So how to tackle such issues? At the time, energy dissipation system will come in picture. And actually, in the new construction, in the if you do some modification in the old structure, that might be called as a rehabilitation, or it might be called as a retrofitting. But when it same method, if you use new construction, that will not be treated as retrofitting, but that will be a kind of the dissipator system that we will consider. So that separate section is there, and that I'll cover along with the performance-based design in the later stage. So now some of the irregularities, again, repeated information. So why this irregularity may create in the structure, issues in the structure? Because if you have some plan irregularity, center of mass and the center of rigidity, it will be acting in a different way. So there will be some eccentricity E will be developed, and due to that eccentricity, the torsion come in the picture. And once if torsion exists, the structure is the failure mechanics of the structure is quite complicated. Complicated in the sense it will not fail only in the shear, it not only in the flexure. There will be some combination of the shear as well as the flexure will come in the picture. So at the time, how to tackle that issues? So that is not so simple. It's not that straightforward also. So I will cover those things also in the later stage. And one of the major issue in the existing building, those who is constructed in a long time back, their main issues is the ductility is a major issue. Why structure is not getting ductility? Because the quality, the construction quality might be poor, and ductile detailing might not be there. So why that ductile detailing? See, if you look in this column, the diagonal shear failure is observed here. So if you look at this reinforcements are quite small diameter, and the concrete quality also not looks so good. And to get the good ductility, the stirrups should be provided in the proper set. 135-degree angle should be provided enough. That already recommended in the IS 1392 as well also. And if you look to the our Bhuj earthquake, the past Bhuj earthquake, the entire structure got collapsed, and this is due to our that low ductility, this profile. And to improve the seismic performance, we need a high ductile behavior structure. And but in the old structure means existing structure, how to get this type of the ductile behavior, that's the questionable. And at any condition, can we use any kind of the retrofitting technique to get a ductile? The answer is no. Actually, you have to think, you have to look what type of the structure is this, and what type of deficiency is there, and based on that you have to choose the retrofitting scheme. So I'll explain. And now same thing is here. How to select your retrofitting method? And retrofitting selection is quite complicated. And first of all, before moving to your retrofitting, you have to look your structure properly. And after looking at structure, again, you have to analyze what type of the deficiency is there in the structure. Might be the flexural deficiency, might be shear deficiency, might be axial deficiency, and or might be the combination of these three. So based on that, you can choose one. There are many kind of the retrofitting techniques are available, uh, and each and every retrofitting technique has their own objective and its own advantage as well as a disadvantage. And based on that, you have to choose one of them. So blindly, you are not supposed to choose any retrofitting technique. So if you choose the retrofitting technique without understanding the basic mechanics, instead of improving the structural performance, your structure also might be more shear. It might be structure might be quite collapse also if you are not doing the if you are not choosing the right methods. Okay, so in that condition, now I can mention what are the available retrofitting methods. That it can be classified into two ways. One is a local and one is a global. And in case of the local, what type of the methods? Under the local, many methods are there. Under the global, many methods are, again, different methods are there. So I will explain what are the local method and the global method. So if you look here, structure here, there's one structure, and in that structure, if you introduce some kind of the bracing system or shear wall, and means if you introduce a totally new element in the building, that's called a global modification. But in that same structure, instead of introducing the new element, if you do some modification in the member level, it might be in a column or it might be in the beam, that will be treated as a kind of your local modification. And what are the advantage and disadvantage of this local modification and the global modification? So it has both advantage and disadvantage. First of all, let's see about this local modification. In the local modification, if you look here, the blue color is the capacity of that existing building or might be the existing structure. So if you do the local modification, you will get a very high ductility. The green color is your updated one, updated capacity. And so if you look in terms of the strength and the stiffness, there is no any much significant improvement. So mild improvement is there, but your major improvement is towards the ductility. Again, when you look to the global modification, the strength and stiffness are quite high, but meantime the ductility is compromised. So it means you are not able to get a good ductility, but strength and stiffness point of view, the global is giving a much more better solution than the local modification. That's why in the initial phase I told how to choose the retrofitting technique and what are the requirements, what is the demand of the data structure. So first of all, you have to identify what is the demand of the that existing structure. Okay, after understanding that demand, we can choose one of the method, maybe from the global or maybe from the local. Again, so from the local point of view, these are some available methods we adopted for the retrofitting. First one is a concrete jacketing and steel casing and FRP wrapping, or maybe the steel fiber concreting. Those are the kind of the local modification. Again, when it came to the global modification, the energy dissipation system, like the friction damper, or maybe yielding damper, or viscous damper, or maybe the isolation system. So these are the kind of the global modification methods, and many other device also is there. So I can't cover all the device here. Some of the popular device only I mentioned here. Now, what is the yielding and what is the viscous, that I will cover in the separate section along with the retrofitting of the case study. And so now, after understanding this local modification, global modification, let's try to understand the two terminology. One is a energy absorber, and the second is a energy dissipator. What is meaning of energy absorber and energy dissipator? What is the role of these two terminology in the field of seismic strengthening or maybe seismic retrofitting? So to understand this terminology, first of all, we have to look a cyclic behavior of the member deformation. And if you look here, this is the loading and again hardening and unloading. So if you look this over entire loading profile, you can calculate the area. And the area under exactly this plot I represent as A1. This is the dissipated energy. Means sometimes we call this is a hysteresis. The area under the hysteresis is the dissipated energy. So, but what is the absorbed energy? So enter the A1 plus this A2. This is the absorbed energy. So usually the absorbed energy concept apply in the field of local modification, and the dissipated energy concept is applied especially for the this one damper base, the global modification. This is for the global base we apply, and this is applied for the local base. But it is not mandatory. But as per the term, most of the conditions are belongs to this global and this local condition. Now, dissipated energy sometimes we can call as a hysteretic device. Now, under the energy absorber, there are various methods are there, but here I highlighted only three. First one is a fiber concrete. Fiber in the sense it might be the steel fiber or might be some natural based fiber. Any kind of the fiber concrete belongs to the energy absorber. Second is the FRP, and third is the high performance concrete. So high performance concrete also is a part of this energy absorber. But in today my talk, I'll concern only about this fiber concrete and FRP. So the high performance concrete will not be covered. Again, when it comes to the energy dissipator, the passive energy dissipators sometimes we call as a passive control device. So some of you might be having idea of passive control and active control. So what is the difference between the active control and the passive control? The active control is a kind of some device is installed in the structure, and with the help of external excitation, or means with the external power supply, the device will be activated during the earthquake or during the natural hazard time, might be cyclone. So the structure will try to protect. That is called active control. And the active control is not so preferable in our industry, because it required always your external power supply, as well as high skilled people required to install such type of device. And sometimes after installation also, due to some issue, the effective that efficiency of those devices not so acceptable condition. And when you look to the passive control, the passive controls belongs is kind of the all kind of the your mm, that damping system, like the bracing, BRB, base isolation, any kind of those external member which you added to the structure and which act by default during the natural disaster time without any external power supply. Those are called a passive control. But in terms of the effectiveness and efficiency point of view, the passive controls are far better than the active control. So in the industry, almost 95% of the construction we use this passive control. Only 5% are use the active control. That's also in the very uh, developed country, especially in the underdeveloped and the developing country. None of the building did not use for the active control. And this passive control, some major devices are the kind of viscous base, isolator, and the yielding base. So these three information I was given as a diagram in some previous slide, but anyway, I'll explain extensively after some few slides. So now, so now from the energy absorber, first of all, let's talk about this fiber base. After the fiber base, FRP will be followed. Then I will move to the energy dissipator capacity. So in the fiber base, still fiber is one of the method which used very effectively in the different field. And steel fiber is made because of the discontinuity, lots of discontinuity wires we put in the concrete, and concrete bonding capacity is improved based on that. And advantages are it reduces the crack impact and fatigue resistance, and the synchronous reduction and the toughness by delaying the crack propagation. Okay, this is the advantage of the steel fiber concrete. And one of the very simple concept, and people always take wrongly about steel fiber. They thought that steel fiber is used for the to improve the strength, but actually it is not correct. So I'll give along that explanation along with the diagram. So first of all, I just give some application of this steel fiber. And in application point of view, the steel fiber is mainly used for the pavement and the slab cladding or flooring or tunnel lining or maybe for the bridge deck. So these are the major application of your steel fiber concrete. Again, there are different type of the steel fibers, straight steel fiber, N hook, pedals, and even in the N hook also different shapes are there, and toothing type surface and wavy type, different. But this N hook is one of the most preferable in the industry, because in the market is very easy to get, and the efficiency of this bonding also quite high compared to the others. So now I try to explain this strength and the stress relationship of the steel fiber. Just now I mentioned that people thought that steel fiber used only for the strength point of view. Actually, if you compare the steel fiber concrete and the normal concrete, and the variation of the strength will not be much different. Of course, steel fiber will give some higher strength, but it is not so significant. But if you look in terms of the deformation capacity, like the strain point of view, that uh, steel fiber has far better than the normal concrete. And the concrete and bricks we treated as a kind of a brittle material. So for that we, and how to find out those performance, simply we did the maybe cube testing or maybe a cylinder testing under the compressive load. And so under the compressive load we can find this the overall the stress strain behavior. So of course the steel fiber will give a very high strain, and here even you can observe here after the failure still the members are not breaking each other, still is holding. So this is the advantage of the steel fiber. So as a result, it used for the this highway construction and all those things. for a rigid highway rigid pavement, usually we prefer to use the steel fiber concrete. Again, now I'm talking about this compressive point of view, but when it came to the tensile. So again, when you look at the tensile property, the steel fiber has almost around 10 to 12 percentage of the tensile capacity compared to the your compressive strength. Uh, but again, when you talk about this normal uh, plain concrete, this around 7 to 10% again. So it means the percentage of the your tensile strength for the normal concrete and the steel fiber is not much different. Of course, there's some mild differences there, but not much different. Again, when you look to the tensile strength point of view, that's it is quite high. And how to evaluate such type of the tensile strength? So usually we try to find out the tensile property of the concrete by the split tensile testing. And the cylinder we keep in the horizontal position, and we did the compressive test. So that's how we find out. But that's the indirect approach. But it is very difficult to predict real tensile stress and tensile strength, and it's very difficult to monitor it. And how to monitor the real tensile strength property of the steel fiber? For that, we have to do a bending test. And in this bending test, here some small that gadget will be installed at the bottom of the beam that is called a CMOD. And with the help of this CMOD, you can measure this entire strength deformation of the steel fiber. So this is the basic difference between a plain concrete and a steel fiber reinforced concrete in terms of the material characterization point of view. So we should be very careful when we use the steel fiber and plain concrete. Some tests are not common. Again, as of now, what I'm talking, the steel fiber is only for the normal construction, this new construction. I mentioned that highway construction and like kind of the flooring and lining of this tunnel. But what is the role of the steel fiber in the seismic rehabilitation and the retrofitting? And of course, the steel fiber will give a very higher capacity in terms of the shear point of view, of course. But in a flexural point of view, it's not much significant. But the shear point of view, steel fiber contribute a lot. But especially when you look to the old structure, and it is not the it is not designed for the ductile detailing. And sometimes that type of the structure we call as a non-ductile concretes. And in those non-ductile concrete, especially the beam column joint, means near to the plastic hinge. And I hope, I assume that all of you already know what is a plastic hinge. In the plastic hinge region, that the chance of concrete crushing and damage is quite high. But how to improve those crushing concrete or maybe the spalling of the concrete, how to improve without much modification of the structure? At the time, steel fiber can take a major role. So in that concern, so I did a one case study. So in this portal frame, these blue highlighted areas are the beam column joint, and these are the plastic hinge joints at the beam column to foundation region. So this concrete has removed, and it is removed, and the new steel fiber concrete has been put it. And similar to evaluate the steel fiber performance, the same dimension of this that frame also casted as a plain cement concrete, and both the frame has been tested under the lateral cyclic loading. And so we compared the advantage of the steel fiber and what is the disadvantage of that plain concrete. We did the comparison. So we can have a small video how that frame is behave during the experimental. Yeah, this is the steel fiber frame, and so now I did not show for that plain concrete frame, so more or less that is look same. Again, this section, this is the steel fiber portion, and this is your plain concrete, and the crack propagation as well as the width of the crack, we did a comparison. And if you look here in the steel fiber, there will lots of micro crack will be there, but the major crack is do not exist. But in case of the plain concrete, micro cracks are very less, but the major shear cracks are developed. So this is more danger than the micro crack. So sometimes we prefer lots of micro crack because it distributes the stress. But when it has a major crack, the total whole damage is concentrated in one point, and chance of collapse or chance of fracture is quite high. So this is the advantage of the our steel fiber we can observe here. So it distributes the stress uniformly. Again, when we compare in terms of the hysteresis point of view, that's normal. This is the hysteresis response of the normal frame, and this is the hysteresis response of the SFRC. And in terms of the backbone performance point of view, the steel fiber has a slightly strength higher, but ductility is better than the normal concrete. Again, similarly for this same concept, not in the component level, this one frame level, but in the component level also we did the experimental. This is a external beam column joint, and we did the modification of the reinforcement and replace this entire beam column joint region concrete by the steel fiber and try to evaluate the performance. And we use a different percentage of the steel fiber ranging from 0.25 to the 1.5%. So this is the all specimen what we carried out in our laboratory. So again, similar concept again we applied for the coupling beam, and even in this the coupling beam, this is the energy dissipator region for the reinforced concrete shear wall. So here also we utilize steel fiber just to see how much energy is released effectively compared to the normal plain concrete, and this is a plain concrete specimen. So these are the comparison between the plain concrete and the steel fiber. The red one is the steel fiber and the black is the normal plain concrete. Of course, the steel fiber has much higher than the plain concrete. So this is the coupling beam test you can observe here. So the damage was totally concentrated at this bottom region, and due to the steel fiber, the concrete swelling that here I did not show for the plain concrete, but in case of the plain concrete, most of the concrete gone. Actually, it's already spalled out. But in case of the steel fiber concrete, the concrete, okay, there is some extent damage is there, but in terms of the that spalling concrete, still is very less compared to the plain concrete. So this is the advantage again. Now, we already know something about this steel fiber. Again, let's come to this FRP. The FRP as an energy absorber. Now, what is the design philosophy and the basic philosophy of this FRP wrapping, and in what condition how to use this FRP that we have to discuss here. And FRP is a kind of the, sorry. So it has advantage in terms of it has high mechanical property. Usually normal steel reinforcement, the yield capacity is Fe415 means 415 MPa, Fe500 means 500 MPa is your yield capacity. But in case of the FRP, it is a very thin layer, but there's yield stress capacity, sometimes 700 MPa, sometimes 900, sometimes 1015 MPa as per the grade of that fiber. So it means it is far much higher than the normal reinforcement, and it is high moisture resistance and the very high chemical environment resistance. And only this advantage is very sensitive to the heat, and the cost wise is not so economic. It is very expensive. This too is the disadvantage for the FRP. And what is the logic behind FRP utilization in the industry? So right now we talk about this steel fiber. Again, coming to that's FRP, and so both has their own application. In case of the steel fiber, we use that steel fiber only for the ductility point of view. Again, here for FRP also can be utilized in the multiple dimension. It be used to improve the this bending capacity, to improve the shear capacity, and and either to improve your axial capacity. So depend on your more of the deficiency, your wrapping method also is different, because sometimes you can wrap in terms of the longitudinal and in terms of the transverse. So first of all, let's try to understand what is this PM interaction curve. In this PM interaction, there is 4 different color codes are there: black, red, green, and a blue. So if you look this black means this is a existing a column capacity. And so in that column capacity, now if you want to improve only the bending capacity, so it means the high lateral force is there, so the bending capacity of the column need to be improved. At the time, what type of the wrapping methods need to be utilized? Because this raise your expected target strength. Because if you look the red and the black, your axial capacity is remain same, but only the bending capacity is improving. And this is the first case. In case of the second condition, you want to improve only the axial capacity. Your column has the axial deficiency, but in terms of the bending point of view, it's okay. Then you can use this the second condition, B criteria. So here your this bending capacity will be remain same, but the axial capacity will be improved. So in some other condition, your column need to be enhanced in both flexural as well as axial. At that time, you can adopt this configuration of the C. It will improve both flexural and axial. So based on your requirement, just I classify as A, B, C. If you choose A, B, or C, you have to orientate your fiber accordingly. And along with the fiber, you can introduce some of the passive reinforcement to improve, especially for your bending capacity, not for the axial. Again, this is for the column modification. But again, when it comes to your beam level, here the black color is the deformation capacity of your beam. So it means it's a purely shear deficient beam. So at any condition, beam will be fail in the shear, because especially such cases happen in the old structure, not for the new design. This is for the old structure. And if you have such kind of shear damage, and anyhow you have to, so in any condition, civil engineers don't want any kind of this shear failure. We want only flexural behavior. So it means performance based design is purely depend on your flexural base, not for a shear base. Okay, so finally we need to convert this existing beam towards the a flexural behavior. Means from the black you have to extend as a kind of this blue color. So at the time, what how to rough your FRP. So in this condition, there might be your beam might be there. So you have to provide a different here at the bottom along the axis of the member. So that's how you can improve the your flexural capacity, and as well as it can improve your shear capacity by wrapping along the this one across this beam. So you can improve the shear capacity. So there's a different wrapping orientations are there. Accordingly, you have to choose it. So now application of the FRP wrapping. Some of the features I can show. This is the beam strengthening, and this is a beam column joint strengthening. And again for the column strengthening, this is the damaged column, and it's the rehabilitated one. So it means now whatever this all wrapping, the basic philosophy is the one which I shown in the graphical, the PM interaction curve and the M5 curve. So that is the main basic philosophy for the FRP wrapping. So some of us we use FRP wrapping without having much understanding that basic principle. Simply we understand that if you wrap something, of course there will be some improvement, but what type of the improvement is there, that you have to understand, and what type of the improvement is required for the structure. So structure might be required for the shear improvement, but if you improve only in the bending, and what is the use of that? So there is no use for that wrapping method. So accordingly, you have to utilize those PM interaction curve and that M5 curve very effectively before choosing the FRP uh, wrapping orientation. Okay, so as a case study, uh, I did a column strengthening in the frame level, and one of the most important after doing the design while you executing the execution in the field is quite tough. So design is a different strategy, and execution is in a different strategy. And and in case of the steel fiber, you need to do a proper mix design, and there should be enough walkability and fill the concrete. But in case of the FRP wrapping, mm, the surface preparation is very, very important, because FRP is a kind of a membrane. Membrane is going to be applied above your column. So if you have rough surface, there is a chance of air bubble inside. Once air bubble is exists in the FRP, that's there's no any use of that. So it can't provide any structure. So it means finally after the strengthening, the FRP and concrete should be a kind of some embedded member. Okay, there should not be any separation in between. If air gap is exists, there is no use. So for that, the surface preparation is very, very important. So in my case, this is a damaged column. So the damaged area concrete already totally removed, and epoxy has applied before putting the new micro concrete. And with the help of the micro concrete, this damaged column has been transformed to the this new column. So in terms of the surface, this is very smooth, and now the edges has been cut it and convert it as curvature form, and finally we wrap the FRP. So means if you plan to wrap the FRP, the surface preparation is very, very important. Without proper surface preparation, even after doing a lots of hard work, you will not get any benefits. So please be careful about this. But such things during the design of the FRP, we are not discuss such issues. So this is the strategy for the execution in the field. So this is the frame overall view, and at the end of the experimental, we observe such kind of the cracks at the beam column joint, and this is the overall hysteresis behavior of the response. Okay, now in terms of the energy absorber, I pick up two topics. One is the fiber and one is the FRP. So this two has been I covered. Next level, let's move to the energy dissipator, the one which I explained in the earlier condition. And the energy dissipation device has, again, same information, the friction damper, viscous damper, and the base isolation, and the yielding damper. So these three, I will not cover. The friction damper, viscous damper, and the base isolation will not be covered. So I will focus more towards the yielding device. The reason is that the yielding device is a part of the passive control, and it has a much more advantage compared to the others method in the sense, like if you look to the viscous damper, is a very expensive. In terms of the efficiency point of view, viscous damper is one of the most highest efficiency, but the difficult the viscous damper is, it's a very expensive. So normal people might not be able to afford that cost. And the friction damper, the disadvantage is, okay, is easy to install, easy to fabricate, but only concern is, of course, the damper means it's going to be exposed in the normal environment, and in the normal environmental condition, you know what happened, that the member will be rusted, and during this earthquake time or maybe the cyclone time, the damper might not be activated properly because of this corrosion and all those things. Oh, again, in case of the base isolation, the installation of the base isolation is not that so simple, and base isolation is good for the new construction, not for the rehabilitation, because in case of rehabilitation, existing structure, you need to be cut the column, discontinue, you have to make it discontinue and insert the base isolation. It is practically it's not so feasible. So base isolation is good for the new practice, not for the rehabilitation scheme. But of course, in some cases, we can apply It did not mean that this is highly restricted for the retrofitting. It did not mean that, but I'm talking about a practical point of view. Again, why I'm focusing on the yielding damper means the yielding damper, that maintenance is zero, you can say zero maintenance, and plus, and there is no any issues in the activation during the earthquake or maybe the natural hazard time. By default, it can activate. So the yielding might be occur in terms of the three-way. One might be in a flexural. So this is the flexural based yielding damper, and second is the shear based yielding damper, and this is the axial based yielding damper. Okay, and so sometimes some of the flexural and shear can be combined, and you can convert it as a kind of the flexural and shear both type of the damper can be fabricated as well. So now when you talk about the yielding damper, try to understand different yielding mechanisms are there: axial yielding, flexural yielding, and shear yielding. So under this three category, a different type of the axials and different type of the flexural, different types of the shears also available, and some of the commonly available things. Uh, I'll just give the extensive information here. So please have a look. This is twin mass damper. The twin mass damper is kind of to control your vibration of the building, and especially such type of the damper installed only at the high level of the structure, not in the ground level. So I'll explain you how to use such type of the technique at what situation in the later stage along with the graphical presentation. Again, the base isolation. So this is another pictures I took from the internet source. Like friction damper, so in the real condition, how the friction damper looks like, and please see, this is a damper size and this height of the person. So how much big damper is exists. Again, this is a viscous damper. I told you that viscous damper is highly efficient damper, but cost wise is not so recommendable. Again, now coming to this yielding device. Among the yielding device, now firstly I pick up the brace system, the bracing system. The bracing system is one of the oldest methods. If you look back, the history of the bracing is started before that many of this metal. The bracing started from our ancient age. Like they use the timber or bamboo as a kind of the bracing member. But again, now I will not look to that timber and the bamboo point of view. But if you look in terms of this metal, and the bracing is member is high effective in terms of the lateral load resisting, but it has some disadvantage. The disadvantage in the sense it is highly effective under the tensile load, but when under the compression load, there is some buckling issue. So due to this buckling issue, the efficiency is not so high, and so now that if you look in the top level, this is almost 1,000 kilometer. But here, if you look here, it's almost minus 800 kilometer. So it is not symmetric condition. And once after buckling, it is degraded, straightly degraded. And so means due to this instability, maybe some premature failure might be observed in the structure. And so this is the only disadvantage in the bracing system, and this is belongs to the axial base damper. Okay, now this axial base damper can be improved this hysteresis performance with the help of the buckling restraint. So now another new device developed based on that is called buckling resisting frame, and in this brace frame the hysteresis behavior will be symmetry. But in case of the buckling frame, only tensile portion will be high effective and the compression portion is not so impressive. But in case of the BRB, both tensile and compression will have the asymmetrical loading profile. And this is the research carried out in the Dr. Safir and Dr. Sau is carried out research, and I just took reference from them. And if you look here, the hysteresis behavior, compression as well as the tension, it has a symmetry nature. So it means in terms of your performance, tension and compression is high effective. Only issue in the BRB is sometimes the premature fracture might be there. So once if premature fracture is occur under the yielding action, under the compression or under the tension, then the chance of some structure instability might be observed. But anyway, such type of the issues can be rectified by choosing a proper cross section and by choosing a different high ductile material, and that can be rectified. So these two I discussed for the axial based yielding device, and after that, now coming to the shear yielding device. So now shear yielding device is the so the working principle is one of the this end will be connected to your structure, might be steel structure or might be a concrete structure, and another end will be connected to the uh, one of the some bracing system. It will be rigidly support. So it means deformation will be purely under the shear. So it means this portion will be as a fixed and upper portion will be acting. So it means entire panel will be under the shear deformation. So that's why this name is called as a shear yielding damper. And in this condition, you'll have a very high strength and high stiffness. So the shear yielding damper energy dissipation capacity is fantastic. It's really awesome, and it will give high strength and high stiffness. But ductility wise, somehow intermediates, not so good. Okay. Again, when it came to the a flexural yielding device, so the difference between a flexural yielding and a shear yielding is, so your plates or maybe the damper will put across the frame, and the deformation will be under the flexural mechanics, not under the shearing. So loading will be under this direction, and this portion will be as a fix only. So it means the deformation is purely under the flexural. So in this condition, you will have a very low capacity in the strength and the stiffness, but it will have very high ductile capacity. So it means all the dampers has their advantage as well as disadvantage. So flexural yielding damper has high ductility but low stiffness and strength, and shear yielding damper has high strength and the high stiffness but intermediate ductility. So in case of the axial condition, so especially for the BRB, it has both a high energy dissipation capacity, and only issue is some premature fracture might be occur. So that is the only concern. Okay, now coming to the earthquake resistance design philosophy. So right now we discuss about this different damper condition and how to utilize those damper in the earthquake resistance design that I'll cover here. So most of you are the faculty, so you know what is a plastic design. So under the earthquake, the structure will deform, and that plastic mechanism will occur. Once if plastic mechanism occur means under the earthquake load, the hysteresis response will be shown. Okay, this hysteresis response can be mathematically we can be convert your input earthquake EI is equal to EK EK means kinetic energy, ED means damping energy, EA means absorbed energy. So now this absorbed energy can be explained in terms of the elastoplastic. This elastic region is a plastic region. So it means elastic plus plastic. Now again, if you rearrange the equation, so now this EA term is finally your EI is equal to the, let's say, your damping energy also split into two ways. One is inherent damping and one is added damping, and the E height is come in the picture. This is the, this EP is replaced by the E height. So now whenever you do any earthquake resistance designs along with the damper, so now if you put some viscous damper, this EA will take care. So if you put some any kind of your hysteretic device like a added damping or maybe the base shear or base isolation or maybe the bracing system BRB or any kind of damper, if you put this E height will be take care. So means this is an energy balance concept. So based on this, that earthquake resistance design philosophy has developed along with this damper. So this is a very basic logic, but sometimes most of us try to look in a different way, and we try to complex ourselves, make it a very complex situation ourselves. So here I just try to represent in a very simplified way. So of course, when you try to find out the E heights and the EDA, there will be a extensive numerical calculation is required. But here I'm just representing the philosophy. Okay, so how to find out E heights and EDA? That's not a straightforward answer. So for that, we have to do a lots of iteration. We have to do many procedures. So I can't give in the one line sentence. Now, coming to this types of energy dissipation device. The same information I already provided, but again, here I am coming how to choose the energy dissipation devices for the seismic rehabilitation method. That's my concern. Again, energy dissipation devices again can be classified into different way: displacement based, velocity based, and the other system. So earlier classification was based on the working mechanism like friction, yielding, and the viscous. But again, those things can be majorly classified into three way: displacement based, velocity based, and the other system. Other means like kind of the acceleration based. Okay, based on that, we have to choose the method of retrofitting. And here, under the displacement base, all the metallic yielding damper and frictions dampers belongs to the displacement base. And viscous fluid dampers are belongs to the velocity based damper. And shape memory allied or twin mass damper base isolation, there belongs to the this one, acceleration base, or maybe the other system. So let's try to understand these three categories very clearly. Otherwise, you will not understand in the next slide what I try to represent. And so why we provide the damper? Because to control the deformation or drift. And anyway, I'll just give in the next slide proper explanation. So if you do a analysis your structure, existing dynamic analysis, so this is called a tripartite chart. So I took this diagram from the A.K. Chopra book. So all of you can look that book as well. And after analyzing that structure, you can get the three sensitive regions. One is the acceleration zone, velocity zone, and the displacement zone. And you have to identify your structure is belongs to the which zone. Okay, if the velocity, your structures lie on a velocity zone, then you can choose one of the velocity-based device. And if structure is lies on a displacement region, then you can choose displacement-based damper. That will be one of the most. This is the basic philosophy how to choose your damper. So some of us simply we try to design the BRB, we try to design the bracing, or we try to design any kind of friction damper. But this is the basic logic why we are going to do the design of the damper based on the structure. This is your highlighting your demand of the structure you are finding out. Okay, the next condition. Next condition is our seismic criteria, seismic based criteria. And now I try to come to the performance-based design. So before coming to the performance-based design, so simply I would like to give some brief information about our Indian seismic code. So in the seismic code, this is the blue color is your response spectra, and this we reduce with the help of the I by R, and base shear is equal to VB is equal to A height W. Now this A height is equivalent to the this is your A height term, okay, the seismic coefficient. And we are not designing the structure as a elastic, so we design for the inelastic, but assuming the characteristic of the elastic. So inelastic deformation structure in the major earthquake, and design method is based on elastic behavior, as I mentioned, and the account for inelastic indirectly. So the inelastic deformation is not counted directly, it's indirectly counted, but your design is purely elastic based. And member sizes has been identified based on elastic design, and it has some drift limitation, and the detailing provisions of ductility is also there. And sometimes the results are undesirable response. The one which I mentioned in the Imphal earthquake, the structure design was did properly, but still structure got failed. So still we can't rely on our design code. So currently our design code can't give any assure your building will not collapse. We can't say that. Of course, we try to do the design with should not be collapsed during the natural hazard. That's our philosophy. But at the end of the design, we can make sure your structure will not collapse during the earthquake. So this is the controversy of the seismic code, not only about this Indian code. And so example is this one. In the 2011 New Zealand earthquake, the one of the building was totally got collapsed. So this is the one reason why we say that we can't rely on the we can't give any assurance on the building design codes at this moment. And this is again same information I given. We did the proper design, but and performance in the past earthquake. In the Northeast earthquake, 70% of the new steel building was suffered. The connection got failed. And in the Kobe earthquake, more than 10% of the new steel building got collapsed. And in the Loma Prieta and the Bhuj earthquake, several new RC building as well as the old building also got collapsed. And the building codes and the design tool. Okay, what are the drawbacks in the seismic design code, especially for the Indian context? I'm not talking about the other ASC code or some European code. So now I'm talking about the Indian IS code. So there is no clear information about the rehabilitation of the existing building. There is some small section, but there's any extensive information is not there. And the design of mechanical equipments and for special structures, that also is not there. And uneven performance code compliant building in a recent earthquake. So means in the recent earthquake, structures are behaving different, but even the design philosophy. That's the point I cover here. And now coming to the performance-based design. So most of us, we heard the term called performance-based design, performance-based engineering design. Okay, but performance-based design is first of all developed based on the displacement approach, and the objective is structure should be safe and life should not be lost. That's our objective. And first performance-based design was developed based on the evaluation and strengthening of the existing building, not for the new building. The currently performance-based design we apply for the new building design, but performance-based design concept and the evolution came only from the retrofitting of the existing building. Okay, that documentation first came as ATC 40 in 1996. That's the first document for the performance-based design. Later on, it came as a FEMA 273 and FEMA 356. In these documents I updated, and finally it can come as a AC 41. So here 2006 I wrote, but the current latest version is a 2017 version. Okay, as for the performance-based seismic design, for the minor level earthquake, building should be in the operable condition. Building should not be damaged extensively, and in case of the immediate moderate level earthquake, the building should be occupancy should be kind of immediate occupancy, and kind of some very rare type earthquake should be gone to the life safety level, and such level of earthquake should happen only 10% in a year in 50 years. So usually we design for the 50 years the lifespan of the building. In the 50 years of the lifespan, only 10% of the earthquake, such type of the earthquake should be faced. That's our performance objective. And again, collapse prevention. The collapse prevention is looking for only 2% in 50 years, and this level is called the MCE. MCE is maximum credible earthquake. Okay, so now if you look at the Indian seismic code, there will be two terms, DBE and the MCE will be there. So whatever our seismic zone factor, zone 2, zone 3, zone 4, zone 5, all the values are based on this MCE. And if you look back, that Z/2 term is there in the seismic code. This Z is for the MCE, and now you divided by 2 is only to convert to your DBE level. So I think yesterday one of the speaker might already given the performance-based seismic design. So I will not spend much time on the performance seismic design. So I'll move to the next level, cooperating to the retrofit. And so after defining that objective and how to evaluate the structure, to evaluate the structure, you have to perform the pushover analysis. This is the recommendation from the FEMA 273 and Hammer 356. And while doing the pushover analysis, you have to assign the non-linear hinge plastic. And in case of the column, you have to apply for the PM interaction type hinges you have to provide. And in case of the beam, the moment curvature you have to provide. And again, for the column in the beam, you can provide a shear damage. So such type of the hinges you have to assign in the structure. And at the end of the pushover analysis, you will get a one capacity curve. Okay, and this capacity curve, how to find out your uh, objective as per your seismic design code. So you have to plot the seismic response spectra as well as your performance curve. And there will be some cross two curve will be bisect each other in one point. That will be your performance of the building that you have to carry it out. So now, after covering this performance-based concept, now I'm coming to the one of the irregularity building. In the irregular building, among the irregular building, so in the initial phase of my slide, lots of irregular building was there. So among that, I pick up this open ground story is one of the irregular building, and this construction is still we prefer. And because we are getting lots of space for the gari parking purpose, or maybe some garage, or maybe some many other aspects, we are getting benefit. So we prefer to construct open ground story building. And advantage in terms of the functional and architectural. And but after having this much advantage, there is some disadvantage also. Those disadvantages are the shear stiffness and strength irregularities are there. Okay, and so such type of the due to such type of irregularity, the building chance of building collapse is quite high, and this type of the failure is called soft story failure. And why soft story mechanism is so complicated, and I'll explain with mechanics. If you look only the frame point of view, your failure mechanism is kind of the frame mechanics. And in that frame, if you put entire infill, the masonry wall, if you put the failure mechanics convert to as a kind of a truss mechanism, this one. Again, now if you remove this open ground condition, and the failure mechanics is a combination of your frame mechanism as well as the truss mechanism. So problem is more complicated. So this is the failure mechanics of the open ground story. And if you look the performance in the past earthquake, in the 1985 Michigan earthquake, there's lots of damage, but 8% is purely contributed only from the open ground story. Again, if you look in the Indian Bhuj earthquake 2001, 1,500 numbers of building is only from the open ground story. So these are the one of the pictures which I took from the internet. And the main issues in open ground story is it has insufficient lateral strength and insufficient stiffness and a limited ductility and inadequate energy dissipation capacity. These 4 points are the major issues in the open ground story, and how to improve that we have to work on that. So based on that, I developed one device. So that's why I explain extensively what is a shear yielding device and this flexural yielding device I explained in the previous slides. So to improve such behavior, you know that shear base has high strength and stiffness, flexural has high ductility. But for open ground story, it required ductility, strength, stiffness. All these 3 parameters are required. So in my study, I proposed this device. Okay, it's a combination of the shear as well as a flexural. And this inner plate is called shear, and outer 2 plates is a flexural. So both the mechanics I combined it and propose a new device, and this is called the combined metal yielding damper. And so this is the overall view of the device. So this device we install in the open ground story, and we did a numerical study and to check the effectiveness and compare without this damper with damper. And as a experimentally, as a case study, I casted a full scale, the half scale Z+1 open ground story. Again, put the damper and did the pseudodynamic testing. The pseudodynamic is a kind of the real earthquake test without check table. With the help of the actuator only we perform. So at the end of the testing without damper, such type of damage is observed. So with damper, without damper, results are comparison. This is the El Centro earthquake. So with and without damper test comparison is shown here. So I will not spend much time here. So let's have look something the interesting results. So you can observe here how structures behave during that El Centro earthquake after putting the damper. So this is the overall condition of the damper at the end of the testing. So let's see how the damper deform for the same experiment. This is only for the damper portion without the frame. Yeah. So this is overall deformation at the end of the experimental. The column was got damaged and the beam column was severely damaged, and the damper deformation is shown here. So in terms of the effectiveness point of view, and usually open ground story building got collapse within just 0.75 to 1.2. This is the collapse region. But in our experimental, it is to the 2.3 here. So it means this much extra drift we are able to gain. And this is equivalent performance of the your normal reinforced concrete, fully infill. So it means whatever the damage observed here, this is at the level of 2.3. So it means our experimental is perfectly fine. So it means usually open ground story fell at 1.75 to 1.2 drift, but we are able to move up to the 2.3. And usually for the normal reinforced concrete, the drift capacity is around 2.5. So now more or less our drift capacity is compared to the normal reinforced concrete building. So means our device is working effectively. So this is a table comparison. So again, this is damper information, how much load is contributed. 105 and 103 push in the pull direction load has taken from the damper point of view. And if you look only the hysteresis, 210 and the 212 load was the push and pull, and out of that 105 plus minus was contributed from the damper. Okay, this is the conclusion for this presentation. The damper, that energy dissipation of the strengthening structure is improved because of the contributed from the CMD, and the deformed configuration of the wave and the in place of CMD, so no premature instability, and a proposed connection scheme work effectively fine. And the soft story, this is one of the most important, soft story in the building behavior has been disappeared. So it means now we can solve the issue of the soft story in the existing building with the help of the proposed device. So this is my overall contents. So I took almost 8 minutes extra, sorry for that. And I cover the energy dissipation and this uh, different damper and how working mechanism, energy absorbers, and I explain extensively local modification, global modification, and the effect of the earthquake and how earthquake generated. So all information I try to cover in this short presentation. So if you look, the first section, earthquake, the earthquake section is a one separate subject called earthquake engineering that will be discussed purely for the earthquake, but I compress within the 15 minutes, and retrofitting rehabilitation, that's a totally different area. So again, I compress in a very limited period of time. So some of the information I might be missed, and in between I introduce the performance-based seismic design compared to the current Indian seismic board. So it means within this limited time of period, I try to cover many other topics. So if I miss some points, so sorry for that. So I hope most of you are able to gain some information from this presentation. So thank you, Professor Ishwara Reddy, for giving this opportunity to me. So now I hand over session to the Professor Ishwara Reddy, so we can discuss something.
Sir,
Yes.
could you please stop sharing this?
Yeah, sure.
Yeah, thank you very much, Dr. Romanbabu. I just summarize whatever we have discussed till now. So, advances in repair rehabilitation and retrofitting methodologies and practices. Under this, he has discussed elaborately about the causes of earthquake and the types of earthquake, plate tectonics, seismic waves that are responsible for earthquakes, then some examples of past earthquakes and their failures, and what are the zones that are available, seismic zones in India. Then he focused on irregularities in buildings that are responsible for earthquake failures. Then source of deficiency that is existed in the buildings. Then he has focused on mode of retrofitting, either local or globally, we need to decide. Then he focused on application of energy absorbers, so and dissipators in seismic retrofitting, such as SFRC, then FRP, and mechanical dampers. Then he focused on earthquake resistant design of structures. So he focused on response spectrum method. So how dampers has to be considered in the design of earthquake resistant design of structures. Then he reviewed some of the codal provisions that were existed, Indian codal provisions. Then he focused on some of the key issues of seismic retrofitting. So how it has to be done and what are the methods available. Then finally, he has ended with a case study. So I thank Dr. Romanbabu for his valuable lecture, especially in the field of earthquake engineering. So seismic evaluation and retrofitting and seismic resistant designs. So thank you very much, sir. So it is a relevant and a contemporary topic. So everybody knows that. So there is a forecast of earthquake in Delhi. Okay, so I don't know whether it is right or wrong, as I just asked Dr. Romanbabu. So to confirm, so there is a possibility of 8 to 9 magnitude earthquake in Delhi, and they're forecasting around 98% of the structures will come down. Well, I don't know. So this is the news I'm reading. So
actually, if you look to our Indian seismic code, the Delhi belongs to the seismic zone 4. So means seismic zone 4 is still a highly earthquake prone area, and so not okay, the 9 magnitude earthquake will be quite tough for that. Actually, I didn't expect, but at least around 6 to 7 level magnitude earthquake possibility is quite high in the Delhi region. But from the Delhi to onward towards this Himalayan region, so the chance of having more high intensity earthquake is quite common. And one more thing, in Delhi, the earthquake is quite common. So actually, my PhD from Delhi, during my PhD time, I faced around more than 5 to 6 times of the earthquake I faced during my daily life. So very frequently, because 3 magnitude, 4 magnitude, 5 magnitude earthquake come very frequently in Delhi. But we can expect more than a higher level. This around 6 or 7 level earthquake also can expect, because Delhi is a highly earthquake vulnerable area. And actually, in the Delhi, many old structures also exist, and they're related to the history, and so people don't want to demolish those type of structure, and so chance of casualty is quite high, especially in those regions. But those building constructed newly, they are quite safe, not an issue. But especially in the Chandni Chowk or some other old Delhi, Purana Delhi, and so there are lots of ancient structure, more than 60 years, more than 70 years, many structures are there. So we can't guarantee anything on that type of structures. So because of that, chance of this one, number of casualty might be quite high if one of the big tremor hit to the Delhi. Possibility is quite high. And personally, in my experience, since I am from Northeast, I faced many major earthquake in my hometown as well. So the one which I mentioned in the Imphal earthquake, 6.7 earthquake, at that time I was in the home. So that was a kind of really, really scared. That moment was really scared. Anyway, fortunately that earthquake came in the early morning, so there was no any casualty. But if that came in the working schedule, that there might be lots of casualty might be there.
Yeah, actually, why I brought to your notice is yesterday I read all these articles. So specialists from different organizations like earthquake study centers are there at Nepal as well as NGRI. So everybody has given their views. So this whatever the tremors that are happening in Himalayan region, so that is the hint for the major earthquake at Delhi. That's what they are forecasting. One person says that no, that may not be true. The other person says that yes, definitely it will happen. Even retired experts.
Yeah, actually,
So,
I also can give some input on that, because chance of high level tremor earthquake is there in Delhi, but not as a 9 level. 9 magnitude is really tough. So we can expect that at least 9 level, at least around 7, 6, 7 or 7.5. That level of the earthquake we can expect for the Delhi.
yeah, they told around 7 to 8 or something, or 8 to 9. So I don't exactly.
Yeah.
So,
So 9 is
yeah,
really
sure.
danger. 9 is
Yeah.
9 is really devastating type. The entire Delhi will be disappear.
Yeah, that's why it is on alluvial soils. So
Yeah.
medium to loose sands. So
Yes.
definitely there will be a liquefaction effect. So possibility may be there. So,
Yes.
sir, shall we take some questions, sir?
Yeah. Yeah. Sure. Sure. We can discuss.
Yeah. So can we use shape memory alloys braces for earthquake resistant of structures in retrofitting method? What are the
Yeah.
limitations?
Of course, that SAP memory AI is one of the new direction in the field of seismic rehabilitation retrofitting. Earlier, we are the one we explained, these are the very conventional bracing of BRB. These are quite old. So nowadays, the SAP memory AI is a kind of some alloy, and which has some self-centering capacity. So means in terms of the resilient point of view, the SAP memory AI is a lot of aspect in future. So especially for BRB and some other existing damper, we try to make using the same memory alloy. Currently, some research is already carried out, and so results also, some of the results also reported. So of course, the set memory alloy is one of the future material for the seismic rehabilitation and retrofitting. But only difficulty is it's very difficult to get material. So the only difficulty.
How column fails in plastic hinge formation location in column in confinement reinforcement length?
So column might be fell in the two way. One is due to the crushing and due to the that that's bending. And under the usually the under the high lateral force, and the column got shear. Shear failure is a quite common failure pattern. And if you look the plastic hinges form, at least as by the thumb rule, depth of the column away from the joint. That's the failure, main failure joint. It will not fail actually at the interface. It will not fail in the beam column joint interface. It will not fail the column foundation interface. At least it will fail at least distance D away from the joint. That's the plastic hinge joint. If you do the plastic analysis properly, of course you can identify what are the plastic zones in the column and the beams. So usually the column will fail at the bottom region, and the bottom column is one of the more high chance to fail and compared to the other columns. Of course other column also might got fail, but bottom column is more danger than the other column.
Yeah, so the other question. So how SFRC will improve the toughness and impact strength in the existing structures through rehabilitation and repair?
That's why actually in the existing, see, first of all, before giving that answer, I would like to give a small briefing about the rehabilitation retrofitting. So in the rehabilitation retrofitting, we try to introduce some new element, even for the still, if you go for the column point of view, you can go for FRP wrapping or maybe steel casing, or otherwise you might be installed some damper in the below the beam. So it means you try to introduce some new material that's the externally. So, but when it came to the steel fiber is a part of the concrete. It's a concrete, you have to fill it. So filling the concrete in the existing structure is really tough. So if you put some membrane, external member, that's quite easy compared to the filling the concrete. That's why filling the steel fiber whole structure is very, very complex. Of course, theoretically, we have the that possibility, but in terms of the practical point of view, if you try to fill the concrete in the entire column, there's a lots of challenges are there, because again the workability in the steel fiber is quite low compared to normal concrete, and the chance of honeycomb formation is quite high if you try to fill the whole entire concrete column. So that's why we identified only some plastic hinge zone, and we fill that concrete in a small region. That's the case study which I shown to you. So it means because of that, again, you know that from the component level testing, you know that the tensile strength of the concrete is quite high. Once tensile strength or maybe the normal strength is quite high, means your toughness will be increased, because toughness is the area under the entire plot. So it means if you have more number of a high strength, means okay, you will have the more area under the stress strength. Of course, you will get the more toughness. But don't try to use the steel fiber to the entire structure. Instead of improving, you might be getting lots of difficulty because of the honeycomb formation.
Yes. Yeah. So, what are the parameters to be used for FEM-based numerical simulation software? Then, how to evaluate them, with what type of instruments we use for evaluating those parameters?
Uh, Professor, your voice was breaking. Can you repeat the question again?
Yes, sir. What type of parameters or properties should be used for FEM-based numerical simulation software? How these properties should be evaluated with what type of instrument?
Actually, when you go for this numerical evaluations, the question is quite is mixing that two questions. I will give answer separately. When you go for the numerical, any kind of the if you want to understand the real behavior of the structure, you should go for the design software, and the this analysis evaluation softwares are different. So design software means State Pro and some other ETAPs. You might be using the industry, because in the design we assume the ideal stress strain behavior. Even if you go to S456, your stress strain is kindly purely parabolic for the concrete, and even for the reinforcement is a kind of elastoplastic type behavior. Means really actual condition there is no such type of the behavior, but you have to do a proper modeling if you want to evaluate the structure. That's the difference between your evaluation and the design. So evaluation means structures already exist, so you want to know the real capacity of the structure. It means you are supposed to be used a real stress strain behavior, not the idealized one. The idealized stress strain behavior is only for design, not for the evaluation. So for that, you have to do the proper characterization. So for the numerically you are doing, but before doing the numerical, you should do a proper experiment like material characterization for the concrete, for the brick, for the reinforcement, with the help of the UTM, with the help of the CTM, you have to find out those stress strain behavior that you are going to be used for the numerical modeling, material property. And after identifying all those things, you should develop your own hinge capacity based on the section property. So now in the numerical modeling, first of all, you should understand what is a material property and what is a section property. So hinge property is nothing. Hinge property means your section capacity is the hinge property, not the material capacity. But your section capacity is going to be calculated with the help of your material capacity. So that's your first question answer. But how to measure that type of the things means one answer is, for the material point of view, UTM, CTM will be your one of the equipment. But in case numerical evaluation, experimentally, if you want to measure the hinge capacity and all those things, you should use some load cell and strain gauges. So some gadget has to be used. You should put some strain gauges in the reinforcement, and during the experimental time, you should monitor through the data acquisition system. You should check what are the level of deformation. Based on that, there is no any exact output will not get. You will get some strain value or some curvature value, and through that you have to calculate some of the back calculation you have to perform. But there is no any moment value, axial value, exact output you will not get. You will get some parameter. Based on that parameter, you have to do some back calculation.
Yes, sir. Next question. When strength of FRP is more than steel, why can't we construct structures using FRP instead of steel?
So one confusion is FRP. I just talk about the tensile. See, FRP seems like a cloth. Now, okay, in front of me, I have this mask. So if I just pull out, this is very strong. FRP is like this only. But if I press, it's like a cloth. Then how we are going to be resist the compressive load? So means in case of the reinforcement, it can take both tensile and the compression load. But FRP is good for the tensile, not for compression. Means FRP seems like a cloth only.
Okay. So why we need epoxy primer before the micro concrete? Will there be proper bonding between the old and new concrete?
So the epoxy primer is required. So see, all concretes and the new concrete, there will be some interface will be there. And we, before putting this one, a primer also, you should chip the concrete, chipping some, you should develop some, you should create some grip. And otherwise, the chance of bond failure will be quite high. See, if the bond between the reinforcement and the concrete is quite strong, but the concrete to concrete bonding, sometimes if you make it very smooth without any some layer, chance of segregation between the old concrete and the new concrete is quite high under the extreme loading. So under the normal loading, there might be any such issue, but under the extreme loading, chance of segregation is quite high. So to avoid such situation, we provide some chipping to get the grip, and after that we provide the epoxy primer.
Yes, sir. Next question. So what about the cost analysis of dampers?
Yeah, so that's the one of the practical based question. So really interesting. So as I mentioned, the if you use viscous damper, the viscous damper is one of the most high efficient type damper. So, but the cost wise, only for a small damper, the minimum price might be around 50,000. But for the average size, the especially used in the highway bridges, the one damper cost might be the 1 lakh or 2 lakhs also. Means if you try to install more than 20 number of damper, then your cost will be spike up like anything. But the one which I met from my study, I proposed, there is very low cost damper, and especially that damper I made for the building application, not for the bridge. Okay, and the building application, and if you have some skill level in the very low cost, we can fabricate it without doing a very high level. This one. Manufacturing industry, by locally we can make that damper, and using the high strength ball, using the mild steel pipe, we need to cut in our proper shape and dimension. So that's how we can make it, but it's a very efficient. So our damper might be around 7,000 to 10,000 cost might be there. If you after applying all this electric bill and the labor cost and minimum cost I'm talking about. But if market point of view, if I say, if I, when we try to sell this thing in the market, there will be some tax will become, GST will come. That's a different concern. So I'm talking about without concerning all those business strategy. If you look only the labor cost and the material cost, is very low price, very low cost.
Sir, where can we accommodate dissipators in a multi-story building?
Yeah, again, that's what I just in between. I hope participants they remember some velocity region, displacement region, explanatory region. The tripartite chart is there. So especially the twin mass damper. Twin mass damper is a kind of acceleration control type damper. So open ground story, I'll talk about. Open ground story is demand is displacement. It has to control the displacement because maximum deformation happen at the ground floor. So whole structure will try to move. But if you install the twin mass damper at the top of the open ground story, what will happen? Instead of improving the building, immediately building will collapse. So in case of the open ground story, you have to choose some displacement control damper, and it has to be installed at the ground floor as per the demand. But in case of regular building which has a very tall structure, like slender, then twin mass damper come in the picture. Normal the bracing or yielding device will not work effectively. So normal yielding device can work effectively in that building if you distribute along the height of the structure uniformly. But if you install twin mass damper at the top of the building, except without any other bracing system, that will control all your deformation and the vibration. So it means depend on your requirement. That's what I say during my presentation. I explain extensively. First of all, you should identify what is the demand of the structure. Is it the displacement demand, velocity demand, or might be the acceleration demand? Once after defining that demand, you choose your device accordingly.
Yes,
So that's
sir.
what I say. That's what I say. Open
Yeah.
ground story building, if you put TMD, instead of improving, immediately building will go collapse. I say during the earthquake.
Okay. How much lapping length required during FRP wrapping of joints?
So I'm not. So I don't have the exact answer for that, but depend on this one. Uh, Almost half of the feet, like maybe 20 mm, usually we provide as a lapping length, but uh, that's also depend on your location, like in a beam column joint or maybe in a column only in a beam. So it depends, but minimum that criteria you can get from the ASE 440. From that also you'll get the different lapping length criteria. So right now I don't have the exact answer for that, but you can refer to that document.
Yes, sir. The next question is, so for a soft story already constructed, so what are the preventive maintenance services to be taken up to protect against seismic activity?
Uh,
Means you left car parking completely without any walls
yeah,
and all.
actually, one answer is okay. All the open ground story is not a weak or is not a vulnerable to earthquake. So see, right now, if you design some of the open ground story, and that might not be required any for the retrofitting. But open ground story, which I represented, that is a very old open ground story which is constructed long time back. And actually, if you look the Indian Seismic Code and 2002, 2000, IS 1993, 2002, and after that, recently 2016 only they upgraded. Is whenever they change the code version, of course the seismic demand is always different. So it means by default you have to do some modification in the structure. But if you do the design as per the current code, there is no any such requirement for the open ground story. But if you look back to the open ground story for all open ground story, of course you have to reanalyze. You have to reanalyze and check the performance. Okay, if the performance is satisfied, there is no required for such type of rehabilitation. And of course, if the performance is underperformed, okay, then you have to introduce some of the retrofitting scheme, like might be the BRB system or maybe bracing, any kind of the that bracing system, temper system can be introduced as a rehabilitation of the open ground. But open ground is the there is one definition. If you look in IS 1993, table number 6 or 7, I forgot. You can say you have this one soap story mechanism if you have the difference of 70% of the stiffness difference between the intermediate floor. So if that criteria is followed, if they are satisfied, no need for doing any rehabilitation. So please have a look that criteria, and when you do the evaluation, please check that criteria is satisfied or not. If not satisfied, then you have to adopt a retrofitting.
Yes, sir. Next question. What is the suitable epoxy quality for FRP wrapping?
Oh, actually, the different resins are there. So that is a very critical question. So even if I give one answer, that will not be applicable to in one side. So this is a very typical type. So I don't have any right answer for that.
Okay. So what is the good ratio of epoxy resin and hardener for FRP wrapping?
Actually, that's what I say. That is purely chemical based. So since there's a during the when we procured this chemical, there's always some instructions are there. The manuscripts are given. Okay, applied 1:2, 1:3, 1:4. So even for us, since we are a civil engineer, we are not a chemical. So we follow the instruction whatever the provided by those company. So especially in this FRP resin and all those things, even I think another civil engineer also can't give that answer directly. So we have to follow the instruction properly, whatever the manuscript already given in that this one container. In that container, you can get some information. You have to follow that.
Yes, sir. So now from my side, I have a question. So
Yes.
techno-legal issues. When you
Mm.
rehabilitate a structure seismic in seismic zone after failure, so what are the techno-legal issues we need to consider? So for example, so I have done my rehabilitation work. So if something goes wrong again, so what is the legal implications that are there?
No,
Is there
actually,
any such forensic studies or something else?
no such forensic study, but when you do this one execute the work, so see, see, rehabilitation retrofitting is it did not came from the different background. Of course, it's
Yes.
related to the your own classical design only, because first of all, stress strain behavior is one of the most important parameter for us. So it means you have to identify a particular for a building. Okay, I need to do modification only in the column. So then I'll do the modification, and that modification will be done based on our IS code only, IS code design criteria. Because whenever we do the retrofitting of the structures, blindly we are not doing. We just follow the design guidelines, and we have to cite it properly. So it means if something goes wrong, also we need to reanalyze. Okay, what we need to reevaluate the structure. Okay, okay, as per the design, the designer, okay, as per this one contractor, did the contractor use the correct method which is recommended by the designer? That we have to look first. And if he used correctly, then we need to look back. Okay, what type of the material he used? Is it the required characteristics is maintained or not? That we have to look at. If that is also satisfied, then we have to look different phase by phase. But there is no any forensic expert or forensic criteria to check such issues. No one will not do that forensic laboratory test, especially for the
So
rehabilitation retrofitting.
yeah, generally these comes under disasters. So when such disasters
Yeah.
happens, for example, a failure of a multi-story building in seismic
Mm.
area,
Mm.
so the governments will take decision as to how to retrofit, what to do. So no builder or owner will not come into picture to take a decision whether he has to
Uh,
rehabilitate in this manner or not, as
yeah,
per the suggestion of
actually,
the.
that decision has been taken based. The government also see government is run by the. They also concerned with the experts. So as per the experts only, they will take the decision. And you know how the decisions take. First of all, they will check the value of the building. And for example, that is your own residential building. Just recently you constructed, and the building was got damaged and not in the good shape. It's a very pathetic condition. Then of course they will not be more concerned about that. Okay, so we'll give some reimbursement and the better to demolish the structure. That type of the decision might come. But instead of that, like heritage structure. So heritage structure has a very high social impact. So it means at any condition we don't want to demolish that structure. So anyhow, we have to bring back that building in the real condition. So it means that decision will be depend on the value of the structure. So means each and every structure has don't have the same value. It has a different value. So that answer also is a very typical. Typical means we need to look to the social impact and the economical impact, and as well as the sympathy of that public. Means many parameters are involved while we taking the decision. It's not only from the structural point of view. Structural point of view, I might say demolish the structure, but from the other point of view, at any condition, it should not be demolished. So then somehow we need to do a lot of modification.
Yeah.
That's
So
not a step.
anybody.
That is not a step forward answer. There is no any step forward answer for that.
Yeah, thank you very much, sir. So,
Yeah.
is there any question from Zoom participants? You can raise your hand.
Professor, so whatever the question answer, that question is coming from the online.
Participants,
Okay.
YouTube, YouTube, sir.
From YouTube
We
only, not from
consolidated
the Zoom
and
people.
we are trying to, yeah, not from Zoom.
Okay.
Zoom only
Okay.
around 30 senior people have been given.
Okay.
So, I'm asking. So, sir, for your information, around 270 people participated on Zoom, sorry, YouTube,
Mm.
and 30 people on Zoom, sir. Total around 300 participants.
Okay.
So probably others will view. So it will be live. So they will view. Thank you so much for your valuable lecture on seismic retrofitting and rehabilitation. Thank you so much, sir.
Thank you, Professor. So it's my
Yeah, sir.
pleasure.
Bye, sir.
Giving
Bye, sir.
for this opportunity. Okay, bye-bye.
Yeah, sure. We'll be in touch with you.
Okay.
Thank you.
Sure. Okay, thank you.
Bye.
Bye.